black holes, journey into the abyss. You know what has always scared and fascinated me at the same time? Somewhere out there in the depths of space right now, there are places from which there is no return. None whatsoever. Even light, the fastest thing in the universe, once it falls in, never escapes. These places are called black holes, and today I want to tell you their story. Imagine for a second that you're standing at the edge of a cliff. Below you is not just an abyss, but a real hole in the fabric of reality. You throw a stone, and it falls and disappears forever. No sound, no reflection, just gone as if it never existed. That's what a black hole is. Only the scale is a bit different. An entire star can fall into one. But let's start from the beginning. It all started over 200 years ago when an English clergyman named John Michell was sitting at home thinking about strange things. He asked himself, what if there's a star so heavy that even light couldn't escape from it? Sound crazy, right? His contemporaries thought so too and promptly forgot about it. More than 100 years passed. In 1915, Albert Einstein turned everything we knew about gravity upside down. He showed that massive objects bend space itself around them. Imagine a trampoline with a heavy ball placed on it. The fabric sags, and everything around rolls toward the center. That's how gravity works according to Einstein. And just a few months later, German astronomer Karl Schwarzschild, sitting in the trenches of World War I, yes, right at the front, solved Einstein's equations and realized something terrifying. If you compress enough matter into a small enough space, space-time curves so much that it collapses in on itself. You get a trap from which nothing can escape. Einstein himself, by the way, didn't believe such objects could actually exist. He thought it was just a mathematical curiosity, nothing more. How wrong he was. Now let's talk about how these cosmic monsters are born. And this is where the real drama begins. Imagine a star, not our modest little yellow sun, but a real giant, 20 or 30 times heavier than the sun. For millions of years it lives, burning hydrogen in its core, turning it into helium, then into carbon, then into even heavier elements. It's like a fire burning from the inside, preventing the star from collapsing under its own weight. But one day, the fuel runs out. At the very center of the star, an iron core forms, and iron is a dead end. It doesn't burn, doesn't release energy. The internal fire goes out, and then catastrophe strikes. Without pressure from inside, gravity wins. The outer layers of the star crash down onto the core at 70,000 kilometers per second. It's like the entire mass of a skyscraper falling onto a pinhead in a fraction of a second. The impact is so powerful that the outer layers bounce off and blast into space in a gigantic explosion. This is called a supernova. For a few weeks, the dying star shines brighter than an entire galaxy. And what happens to the core? It keeps collapsing. Atoms are crushed. Electrons are forced into protons. Matter becomes unimaginably dense. If the mass is great enough, nothing can stop this collapse. Matter compresses into a point, space around it closes in, and a black hole is born. All of this takes less than a second. There was a star, and now there isn't. Just an invisible vortex in space that will exist for an unimaginably long time. You know what's strangest about black holes? They're surprisingly simple. They have only 3 characteristics: mass, spin, an electric charge. That's it. It doesn't matter what the star was made of, what color it was, how many planets it had. The black hole forgets everything. Physicists joke that black holes have no hair. They're all equally bald, but their sizes vary enormously. The most common are stellar black holes. They weigh as much as several suns, but you could fit one within the city limits of Moscow. Imagine the mass of 10 suns compressed to the size of a small city. There are hundreds of millions of these in our galaxy, by some estimates. They hide in the darkness, invisible until something gets too close. And then there are the real monsters, supermassive black holes. They sit at the centers of galaxies like spiders in a web. Our Milky Way is no exception. At its heart lurks Sagittarius A-, a black hole with a mass of 4 million suns. But that's nothing. The record holder, Tion 618, weighs 66 billion solar masses. 66 billion. Our entire solar system would fit inside its event horizon, several times over. How such giants grow, that's a mystery. Maybe they started small and grew over billions of years, devouring stars and gas. Or maybe they appeared already huge in the first moments after the Big Bang. We don't know yet. All right, let's say you somehow ended up near a black hole. What would you see? First, you'd see darkness, but not ordinary darkness. How can I put it? A hole in the stars. A place where stars should be, but aren't. Blackness blacker than space. Second, around this blackness, you'd see madness. Light from distant stars bends as it passes by the black hole, like water flowing around a stone in a stream. Stars that are directly behind the black hole, you'd still see them. Their light bends around the event horizon. The image would be distorted, twisted, as if looking through warped glass. And if the black hole is actively feeding, then you'd see a real show. Gas falling onto the black hole spirals into a superheated disk. It heats up to millions of degrees from friction, glowing brighter than a star. This is called an accretion disk, and some of them are visible from billions of light years away. Sometimes jets of plasma burst from the poles of black holes. They travel at nearly the speed of light and can stretch for hundreds of thousands of light years. Imagine an object the size of the solar system firing a beam longer than the distance between galaxies. And now, for the most interesting part. What happens if you decide to dive into a black hole? Let's say you're flying toward an ordinary stellar black hole, feet first. As you get closer, you'll notice something unpleasant. The gravity at your feet will be significantly stronger than at your head because your feet are closer to the center. This difference will stretch you. First a little, then more, then a lot more. At some point, you'll literally be stretched into a long, thin thread, like spaghetti. Scientists actually call this process spaghettification. I'm not kidding, it's an official term. But here's what's strange. If the black hole is big enough, supermassive, the tidal forces at the event horizon will be weak. Theoretically, you could cross the event horizon of a supermassive black hole alive and not even notice the moment. No wall, no barrier, just an invisible line beyond which there's no way back. And that's when things get really weird. For you, time would flow normally. You'd cross the horizon, maybe even have time to think about something, and then you'd fall into the singularity, the point at the center of the black hole where our physics stops working. What happens there, nobody knows. Maybe it's the end of space and time. Maybe a passage to another universe. Maybe something we can't even conceive of. But here's what your friend who stayed outside and is watching you through a telescope would see. They'd see you approaching the event horizon and slowing down. Time for you, from a perspective, flows slower and slower. You become redder and redder. This is called gravitational redshift, dimmer and dimmer. And eventually you freeze at the very edge of the horizon. Forever. Well, almost forever. Your image would become fainter and fainter until it disappeared completely. So there's a paradox. For you, falling into a black hole takes finite time. But for an outside observer, infinity. Time inside and outside a black hole flows completely differently. Remember the movie Interstellar? The heroes spend an hour on a planet near a giant black hole, and 7 years pass on Earth. That's not fiction. That's real physics, just taken to the extreme. In April 2019, something happened that many didn't believe possible. We saw a black hole. Actually saw it. The Event Horizon Telescope project united radio telescopes across the planet, from Hawaii to Antarctica. Together they worked as one giant telescope the size of Earth. 2 years of data processing, and there it was, a blurry orange ring with a dark spot in the middle. A black hole at the center of galaxy M87, 55 million light years away. That orange glow is superheated gas from the accretion disk, and the dark spot is the shadow of the black hole, the region from which light cannot reach our telescopes. I remember that day. The internet exploded. People looked at a blurry picture and understood. We had just seen the invisible. We had photographed a hole in space-time. 3 years later, in 2022, the team showed a photo of our own black hole, Sagittarius A, at the center of the Milky Way. Our personal monster, sitting just 26,000 light years away. By cosmic standards, within arm's reach. For a long time, everyone thought black holes were eternal, that once they appeared, they would exist until the end of time. But in 1974, Stephen Hawking changed everything. He showed that black holes slowly evaporate. How does it work? Quantum mechanics says that vacuum isn't empty. Pairs of particles and antiparticles constantly appear and disappear there. Usually they immediately annihilate each other. But near the event horizon, one particle can fall into the black hole while the other escapes into space. To us, it looks like the black hole is emitting radiation. This radiation carries away the black hole's mass. Slowly, unimaginably slowly. For an ordinary stellar black hole to evaporate, it would take a time written as 1 with 67 zeros after it. The age of the universe is 13 billion years. These are just incomparable numbers. But small black holes evaporate faster. The smaller the black hole, the hotter it radiates, the faster it loses mass. At the very end, when the black hole becomes tiny, it explodes in a burst of gamma rays, a final chord before disappearing. And here's where a paradox arises that physicists are still wrestling with. If all information about what fell into the black hole is lost forever, and then the black hole evaporates, where does that information go? The laws of quantum mechanics forbid the destruction of information. Something doesn't add up. Either Hawking was wrong, or Einstein, or quantum mechanics. Or we don't understand something about the very nature of reality. You know what amazes me most about black holes? They're nothing like what movies show. They don't suck everything in like cosmic vacuum cleaners. If the sun suddenly turned into a black hole of the same mass, Earth would continue orbiting on the same path. We'd just freeze in the darkness, but we wouldn't get sucked in. Some black holes sing. In 2003, astronomers discovered that the black hole in the Perseus galaxy cluster emits sound waves. The lowest note in the universe, B-flat, 57 octaves lower than we can hear. The sound travels through hot gas between galaxies. The nearest known black hole is about 1,500 light years away. That's far by human standards, but by galactic standards, a neighbor. And surely there are closer ones. We just haven't found them yet. They hide in the darkness, giving no sign of themselves. Some black holes spin so fast that their event horizons move at nearly the speed of light. Imagine a top spinning so fast that its edge blurs into a flash of light. And one more thing that boggles the mind. Black holes are the most efficient energy sources in the universe. The accretion disk converts 40% of falling matter into pure energy. Nuclear fusion in stars converts less than 1%. If we could harness a black hole, 1 kilogram of fuel would power all of humanity for a year. What awaits black holes in the distant future? In trillions of years, all stars will burn out. Galaxies will become dark graveyards. Black holes, cool dwarfs, neutron stars. Gradually, black holes will grow, devouring everything that comes near. At the centers of galaxies will sit colossal monsters that were once supermassive and have become even more so. But even they aren't eternal. After a time that's impossible to comprehend, one with 100 zeros after it, the last black holes will evaporate. The final flashes of Hawking radiation will be the last light in the universe. After that, only cold and darkness. Forever. But you know what? That's so far away. There's no point in being upset. The current age of the universe, compared to that time, is like 1 second compared to all of human history. We've learned a lot about black holes in the last 100 years. We predicted their existence, found them, photographed them. We heard gravitational waves from their collisions, ripples in the fabric of space-time that reached us across billions of years. But there are even more mysteries left. What's inside? Our equations say a singularity, a point of infinite density. But physicists suspect that just means our equations stop working. We need a new theory, quantum gravity, to understand what's really there. Where do black holes lead? Maybe nowhere. Or maybe to other universes. Maybe they're connected by wormholes. It's all speculation for now, but who knows? Maybe in 100 years this will be in textbooks. Where did the supermassive black holes in the early universe come from? We see them just a few 100 million years after the Big Bang. How do they grow so fast? Either they were born big, or they grew in some way we don't understand. Black holes aren't just strange objects in pictures. They're windows into the deepest secrets of the universe. They show us where our knowledge ends and the unknown begins. Right now, while you're reading this, somewhere in space a black hole is tearing a star apart. Somewhere 2 black holes are spiraling in a death dance, about to merge and send gravitational waves across the universe. Somewhere a supermassive monster is shooting out a jet of plasma that will stretch for 1,000,000 light years. And we sit on a little blue planet and try to understand it all. And you know what? We're succeeding. Slowly, step by step, but succeeding. If you enjoyed this story, hit like and subscribe to the channel. Space is full of stories, and I want to tell you all of them. See you among the stars.